This is lesson 8-2, all about the Pythagorean Theorem and its converse. And this will be one video, there's not two parts. Hopefully a shorter video, I'll do my best. Pythagorean Theorem is kind of a review. You guys should have seen this in middle school math before. Basically, it's whenever we have a right triangle. Let me zoom in here. A right triangle has a 90-degree angle. The side across from it is the longest side of the triangle, and it's called the hypotenuse. And then the other two sides are just the legs of the triangle, and they could be the same size, or one could be shorter, one could be longer. It just depends. But 90-degree angle, hypotenuse, right? So we always call the hypotenuse side C, and then the two legs are just A and B, and it does not matter which is which, right? So the Pythagorean theorem is a squared plus b squared equals c squared. So basically we take the length of the two legs, we square each of them, we add them together, and that should be equal to the longest side squared, right? They should be equal if it's a 90-degree angle. So for example, here we have two legs, A and 12, and the hypotenuse is 13. So when we use the Pythagorean theorem, we square one leg, add it to the square of the other leg, and that should equal the hypotenuse squared, the longest side squared, right? So here we can actually solve for A. So A squared plus 12 squared is 144 equals 13 squared is 169. I'm going to subtract 144 from both sides of my equation. And these go away, and I'm left with A squared equals 169 minus 24, or 144 is 25. And then I don't want to know what A squared is, I just want to know what A is. So I'm going to take the square root, and I'm going to take the square root, and so A will equal 5, right? And that's what they got down here, A equals 5. So this missing side here is 5. 5 squared plus 12 squared equals this longest side squared. Okay, we have another example here. We've got our two legs, and then for all of these problems in this on this worksheet, I've highlighted the hypotenuse just to kind of visually keep it set aside. So I'm going to add the square of these two together. So 20 squared plus 30 squared, and that's going to add up to c squared. Okay, 20 times 20 is 400. 30 times 30 is 900 equals c squared. 400 plus 900 is 1300 equals c squared. And then when we take the square root of 1300, it is not a perfect square. So we would get something we'd have to estimate, right? So it would be about 36.1. It's down here. Okay, now typically we don't like to estimate. We want to keep things as accurate as possible. But when a number is actually referring to the size on a part of a shape, so the length of a side of a triangle, the length of that, right, the size of that side, we do want to get a good feel for how long that is. So we are going to change it from the square root of 13, right? If somebody said, your little brother is the square root of 1,300 inches tall, you're going to be like, huh? I don't know what that means. But if they said he's about 36.1 inches tall, you can figure out, okay, he's about 3 feet tall, right? That's a little bit easier. So when it refers to something like a shape, something tangible you can touch, then we are going to estimate it. So square root of 1,300, or 1,300 equals c squared, take the square root of both sides, and then we estimated this. Okay, so for all of these, we're going to do the exact same thing. So it's a leg squared plus a leg squared equals the longest side squared. So here, 3 squared plus 3 squared equals x squared. Okay, excuse me, 9 plus 9 equals x squared. 18 equals x squared. We're going to take the square root, and 18 is not a perfect square. When we take the square root of 18, square root, it's about, let's say, 4.24. Does it say what to round? No, so you could leave it here. We're gonna round it to let's just round it to the nearest tenth, 4.2. Let's round it to. So x equals about, that little wiggly equal sign means estimated, 4.2 units. Okay, next problem. We have a leg squared plus a leg squared equals a hypotenuse squared. So 9 squared plus x squared equals 15 squared. 81 plus x squared equals 225. We're going to subtract 81 from both sides. So x squared equals 225 minus 81. I think I know it. We're going to check. Yep, 144. And 144 is a perfect square. When we take the square root, we get x equals 12. Okay. Next one, number 3. A squared plus b squared equals c squared. 25 squared plus x squared equals 65 squared. Fit it all in, yep. I don't know what 25 squared is. It's a big number. 625, I should know that. 625 plus x squared equals 4225. And then I'm going to subtract 625 from both sides. 3,600, that is also a perfect square. If we take the square root of 3,600, we should get 60. Okay, so the length of this side is 60. 25 squared plus 60 squared equals 65 squared. Hopefully you guys remember this from earlier math. Number 4. X squared plus 4 over 9 squared equals 5 over 9 squared. Ooh, fractions. All right, and so we want to go straight across the top, straight across the bottom. We're going to keep this as x squared. 4 squared is 16. 9 squared is 81. 5 squared is 25, 9 squared is 81. So what over 81 plus 16 over 81 equals 25 over 81, right? 9 over 81. So this has to be equal to, x squared has to be equal to 9 over 81, because 9 plus 16 equals 25. They all have to be over 81. But I don't want to know what x squared is. I want to know what x is, so I'm going to take the square root. And the square root of 9, I'm working backwards here, the square root of 9 is 3, and the square root of 81 is 9, and I can still simplify 3 over 9. I can divide the top and the bottom by 3 and get 1/3. So our answer there is 1/3. The length of this side right here is 1/3. 1/3 squared plus 4/9 squared equals 5/9 squared. Okay, next one. Now we've got a rectangle, but we're kind of ignoring this and this for a second. We're just focused on the same triangle we've been looking at, right? So 16 squared plus 33 squared equals x squared. You gotta have your calculator handy for these big guys. 256 plus 33 squared, 1089 equals x squared. Can you see that? Yes. If we add those together, we get 1345. And then if I take the square root of both, I get about 36.7. So x estimates at 36.7. It's a long decimal, but I'm just rounding. Which makes sense. 16, 33, and the longest side is a little over 36. Makes sense. Okay, for number, 6? We have these 4 triangles, right? But we don't care about all 4. We just care about one of them. So we're ignoring all of this right now. None of this matters. We are just focused on this one triangle. So here's my hypotenuse I highlighted. Leg is x, leg is 11. So x squared plus 11 squared, and that should equal 28 squared. That's still on the, yep. All right, so x squared plus 121 equals, I don't know what 28 squared is, 784. minus 121 on both sides, 663. And then I take the square root, and the square root of 663 is about 25.7. Seems kind of big. Oh no, because the hypotenuse is 28 and this is less than that. So that makes sense. Makes sense. Just make sure when you find your two legs, if you're looking for one of the legs, they should both be smaller than the hypotenuse, or vice versa. If you're looking for the hypotenuse, it should always be longer than the two legs, right? Okay. Use Pythagorean triple to find x. We're going to get into specific Pythagorean triples here in just a second. But here, same concept. So a squared plus b squared equals c squared. X squared plus 8 squared equals 17 squared. X squared plus 64 equals 289. Minus 64 on both sides, 225. And the square root of 225 is, anybody know? I actually know that one, 15. And full disclosure, whenever you take the square root of something, the answer actually could be positive or negative, because the square root of 225 is whatever number you multiplied by itself to get 225. I could have multiplied 15 times 15 to get positive 225. I could have multiplied negative 15 by negative 15 to get 225, right? But since these numbers aren't just numbers, they're actually referring to lengths of the side of a triangle, then they can't be negative. So we're just picking the positive value. Okay, next one here. It's really hard to read in the camera. 45 squared plus 24 squared equals x squared. So big numbers. 2025 plus 576 equals x squared. Add those together. 2601. And this is also a perfect square. 51. X equals 51 exactly. And last but not least, number 9, last one on the front of this paper. 28 squared plus 96 squared equals x squared. I'm going to give you a shortcut here on the back side of this paper in just a second where you don't have to do all this math. You have the shortcut to it. But for right now, it's good practice. All right, 28 squared, 784, 96 squared, 9216, oops. Yep, 9216 equals x squared. That's 10,000. And the square root of 10,000 is 100. So if this side is almost 100 and this side's 28, it makes sense that this longest side here is 100, right? It's close to this, but more than that. All right, so here's what I wanted to show you, and this is all in one video. We finished the front side. Something called a Pythagorean triple. Okay, so we have this little chart. Let me back up. Pythagorean triples are basically when you have whole numbers that all three make up the sides of a right triangle, right? Without having any decimals. So remember on the front of this paper how we had a few problems where, like number 1, where 3 squared plus 3 squared doesn't give us a whole number squared here. It's 4.1 blah, 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 or 4.24 blah, 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 and we had to kind of estimate it, right? Well, that wouldn't make up a Pythagorean triple. Pythagorean triples are made up of just whole numbers. That's it, right? So here, 3 squared plus 4 squared equals 5 squared, right? So these three numbers could be sides of a right triangle. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, which is 5 squared. So this is a common Pythagorean triple. Same thing here. 5 squared is 25, 12 squared is 144. 25 and 144 equals 169, which is 13 squared. So this squared plus this squared equals this squared. The biggest number listed in each triple, it represents what the hypotenuse length would be. Sorry, you're looking at that crooked. Okay, there's also variants of this, or not variants, but multiples of this. So I could take each of these three numbers and multiply it by 2, and I would get 6, 8, 10. So that's also a Pythagorean triple, right? 36 plus 64 equals 100. 6 squared is 36, 8 squared is 64, 10 squared is 100. So that works. I can multiply them all by 3. 3 times 3 is 9. 4 times 3 is 12, 5 times 3 is 15. That's another Pythagorean triple. So definitely copy this down. You're gonna see these numbers here in a second. You're gonna see these a lot. There's others too, these are just common. Okay, 5, 12, and 13. This is a Pythagorean triple, so then we can come up with multiples of that. Multiply everything by 2. 10, 24, 25. 10 squared plus 24 squared equals 25 squared. You can use your calculator to double check it if you don't believe. Then multiply by 3. 5 times 3 is 15. 12 times 3 is 36. 13 times 3 is 39. Same thing. 15 squared plus 36 squared equals 39 squared. I'm going to do it again. 8, 15, 17. That's another Pythagorean triple. We can multiply everything by 2. 16, 30, 34. We can multiply everything by 3. 24, 45, and 30 and 21, 51. And then 724, 725. Now it still keeps going up from there, but this is where I stopped because I don't want to get into humongous numbers. So I can multiply everything by 2, 48, 50. Or I can multiply everything by 3, 21, 672, I believe. And 75. Right, so this chart here, if you want to copy it down, pause it if you need to. These are common Pythagorean triples. The triples are just these 4 at the top, the common ones that I listed, and then everything below them are just multiples of them. So yeah, you could see 9, 12, and 15. That is a Pythagorean triple. It's a multiple of the original triple, which is 3, 4, and 5, right? These are multiples of 5, 12, and 13. These are multiples of 8, 15, 17. And these are multiples of 7, 24, 25. You could also make your chart keep going. You can multiply these by 4 and get more numbers. You can multiply these by 4. You can multiply by 5. You can make this chart as big as you want. But, you know, I don't think you'll deal with a whole lot of numbers like that. Okay, so on the front. Now I'm going to be flipping back and forth here, looking at these in a second. Here we have a little hint. Okay, so what if we use the Pythagorean theorem, but they're not equal? What if we have the 3 sides, but they're not equal? What does that mean? It means that the triangle is not a right triangle. The Pythagorean theorem, a squared plus b squared equals c squared, only works for right triangles. That's it. But we can still use the Pythagorean theorem for other triangles, right? So a squared plus b squared, and then we have c squared. If the longest side squared is less than the other 2 squared added together, then it's an acute angle, right? Meaning all the angles in the triangle are less than 90. If the longest side squared is bigger than the other 2 legs squared added together, then it's an obtuse angle, which means an obtuse triangle, which means one of the angles in the triangle is bigger than 90. So it's either going to be exactly a right triangle if the 2 legs squared added together equals the third side squared, but then a lot of times they aren't going to be perfectly equal. So if the 2 legs squared added together are greater than the third side, it's an acute triangle. And if it's less than the third side squared, then it's an obtuse angle. So you're going to use this to answer some questions down here. Okay, another thing we're going to be doing is checking to see if the directions here say determine whether each set of measures can be measures of the sides of a triangle. Well, what the heck does that mean, right? So another thing we want to do is just make sure at all times that any 2 legs that we add up of the triangle have to be greater than the third leg, right? So if I added, let's see, for this very first, do I have one already? That one, I don't want to do that one. For number 1 here, we'll just start there. 30 plus 40 has to be bigger than 50. And 30 plus 40 is 70, and 70 is bigger than 50, so we're good, right? Then we can add 2 more. 30 plus 50 has to be bigger than 40. 30 plus 50 is 80, and 80 is greater than 40. 40 plus 50 has to be bigger than 30. 40 and 50 is 90, and that's greater than 30. So we should be able to add any 2 legs together, and they have to be greater than, the sum of those 2 legs has to be greater than the 3rd leg that we didn't add together, right? So if that's true, which in all cases here it is true, then these could be sides of a triangle. Okay, then I want to use, answer the second part, which says, if so, classify the triangle as acute, obtuse, or right. And then, of course, justify your answer means show your work. So we're going to use this little guy up here to figure out if it's acute, obtuse, or right. Okay, so I'm going to square the 2 smaller legs, add them together, and they should be equal to, well, they will be equal to, less than, or greater than the hypotenuse squared. The hypotenuse is the biggest side, so I went ahead and, I guess it's not even, you don't even think of it as a hypotenuse. You want to make sure that this plus this, the 2 smaller legs squared added together, are equal to, greater than, or less than the biggest leg squared. Right? That's what we're trying to determine. And depending on what it is, it will depend on what type of triangle it is. All right, so 30 squared plus 40 squared, and then I have 50 squared over here, and I don't know if they're equal yet, or greater than, or less than. I don't know. 30 squared is 900. 40 squared is 1600. And 50 squared is 2500. And if I add 900 plus 1600, I get 2500. So these are equal, which makes this whole triangle here a right triangle. When a squared plus b squared equals c squared, then it's a right triangle. Okay, next one. First off, I got to be able to add up any 2 legs, and they have to be bigger. That sum has to be bigger than the 3rd leg. So 20 plus 30 is 50. 50 is bigger than 40. That works. 20 plus 40 is 60. 60 is bigger than 30. That works. 30 plus 40 is 70. 70 is bigger than 20. That works. So all of these sides can be sides of a triangle. And then I got to figure out 20 squared plus 30 squared. What's its relationship to, or relation to, 40 squared? So that's 400 plus 900. And 40 squared is 1600. 400 plus 900 is 1300. 1300 is less than 1600. So since the biggest side squared is larger than the sum of the 2 smaller sides, if that's the case up here, if it's larger, this is bigger, the mouth is open towards this guy, then it's an obtuse angle. Okay, this is larger, so it is obtuse. Okay, next one we want to do is this guy. So first off, we got to add every possible combination of 2, and it's got to be bigger than the 3rd, right? So 18 and 24 is 42. Is 42 bigger than 30? Yes, it is. 18 and 30 is 48. Is 48 bigger than 24? Yes, it is. 24 and 30 is 54. Is that bigger than 18? Yes, it is. So these can all be sides of a triangle. And then I want to figure out what type of triangle it is. So I got the 2 smaller legs. I square them and add them together. And then I've got the biggest side here. Okay, so then I got to use my calculator. 18 squared is 324. 24 squared is 576. And 30 squared is 900. And if I add 324 plus 576, I get 900. So 900 equals 900. So this must be a right triangle. Okay, hopefully this is making sense. So we're doing 2 things. We're making sure that the 3 sides can be sides of a triangle, that mathematically that works. And also we're classifying it by the type of triangle. So is it right, is it acute, or is it obtuse? Remember, an acute angle is an angle with, acute triangle is a triangle where all three angles are less than 90. An obtuse angle or obtuse triangle, it has one angle that's greater than 90, right? And then of course a right triangle has one angle that's exactly 90. Okay, 6 plus 8 is 17. 17 is bigger than 9, perfect. 8 plus 9 is 17. No, just did. Oh, 6 plus 8 is 14. 14 is bigger than 9, true. 8 plus 9 is 17. 17 is bigger than 6. 6 plus 9 is 15. 15 is bigger than 8. So yes, this is true. These can be sides of a triangle. And then I want to look at 6 squared plus 8 squared and compare it to 9 squared. That's 36 plus 64 and then 81 over here. This is 100. This is 81, so this is bigger. So this biggest side squared is less than the sum of the square of the other two sides, right? So when it's less than, it's actually an acute triangle. So it is a triangle and it's an acute triangle because the biggest side squared is smaller than the sum of the other two squared sides. Okay? Number 5. 6, 12, and 18. 6 and 12 is 18. Is 18 bigger than 18? No. So these cannot be sides of a triangle. 6 plus 12 equals 18. And because it's equals, cannot be sides of a triangle. Remember, when you add two legs together, they always have to equal something bigger than the third leg. And in this case, that's not true. It's actually equal to the third leg. So this can't be sides of a triangle. So we don't have to go any further. Number 6 now. 10 plus 15 is 25. 25 is greater than 20. Good. 15 and 20 is 35. 35 is greater than 10. True. 10 and 20 is 30. 30 is greater than 15. So this works. These can be sides of a triangle. And then I want to use the Pythagorean Theorem, 10 squared plus 15 squared, and then something about 20 squared. That's 100 plus 225. 20 squared is 400. 100 plus 225 is 325, and 325 is less than 400. So since the third side squared is greater than the other two, this should be an obtuse triangle. Okay, number 7, 5, 12, and 13. One thing I want to show you here, because we just went over it, 5, 12, and 13, it's all square roots, right? These are, wrong paper, might be. Oh, here. 5, 12, and 13 are a Pythagorean triple, right? They make up a Pythagorean triple. So does that work with these? Well, let's go ahead and change them to decimals, and we can just make sure that they can all be sides of a triangle. Let me find my calculator. All right, square root of 5 is 2.24. 2.24. Square root of 12 is 3.46. And square root of 13, oops, you can't see that, is 3.61 about. So we got to make sure when we add 2 together, they're bigger than the third side, right? So 2.24 plus 3.46, 2 plus 3 is 5, and that's already bigger than 3.61. 3 plus 3 is 6, that's bigger than 2. I'm just ignoring the decimal for a second. I just got to make sure these two are bigger than this guy. And then 2 plus 3 is 5, and that's bigger than this. So yes. Okay, next thing I want to do is use Pythagorean Theorem. So I've got square root of 5 squared plus square root of 12 squared, and then square root of 13 squared. Right? Square root of 5 squared is just 5. Square root of 12 squared is just 12. The squared and the square root cancel each other out. Add them together. Square root of 13 squared is 13. 5 and 12 is 17. These are obviously not equal. 17 is greater, which means the biggest side, the third side, when we square it, is smaller than the sum of the other two sides squared. So this is an acute triangle, not a right triangle. So it didn't matter that they were Pythagorean theorems because we took the square root anyway, so it didn't correlate. Okay, and then number 8. 2, square root of 8, square root of 12. All right, so square root of 12 we just found out was 3.46. The square root of 8 is 2.83-ish. 2.83. So this is almost 3. This is about 3.5. We just got to make sure when we add any two together, they're greater than the third side. So 2 plus 2 plus 2 is 4. 4 is greater than this guy. 2 plus 3 is 5. 5 is greater than this middle guy. And 2 plus 3 is 5. 5 is greater than 2. So yes, that works. These can all be sides of a triangle. What kind of triangle? Let's square everything. 2 squared plus square root of 8 squared, and then square root of 12 squared. So that's 4 plus the square root of 8 squared. These two cancel each other out. It's just 8. Here, these cancel each other out, and that's just 12. 4 plus 8 equals 12. So these are equal, and this is a right triangle. And then lastly, number 9. Oops. When I add 40 and 9, they add up to a number bigger than 41. 49 is bigger than 41. When I add 9 and 41, that's 50. 50 is bigger than 40. And when I add 40 and 41, that's 81, which is bigger than 90. So yes, these can all be sides of a triangle. And then I got to figure out what kind of triangle it is. So 9 squared plus 40 squared, and then over here, 41 squared. 9 squared is 81. 40 squared is 1600, and 41 squared is 1681. So obviously, if I add these two together, they're going to equal 1681. So this is a right triangle. When they're equal, it's right. When this number over here is bigger, when the mouth is open towards this number, it's obtuse. When it's smaller, when the mouth is open towards this side, it's acute. Okay, so hopefully that made sense. If you have questions on any of this lesson, let me know.